Today we're going to look at solving systems by graphing. So when we talk about a system of equations, what we mean is that we have two or more equations. So when we say systems, we just mean multiple equations. In our class, we'll typically be dealing with linear equations, so just lines, and we'll usually just have two. But you could, and you will learn in future math classes, that you can work with more equations at a time. When we say solve or find the solution to a system is the point of intersection. So where the two lines run into each other is your solution. That would be the point or the values that make both equations true. There are a couple different things that can happen when we talk about solutions though. Most basic one is when you just have one solution. So that would be a scenario where you have two lines that cross. Actually, let's do this in color. I'm going to use two colors. We've got two lines that cross and run into each other. That point of intersection is the one solution. Two other options. Sometimes you'll have no solution. So if we say no solution, we mean the lines never run into each other. And think about what we've been learning. For two lines to never run into each other, they are parallel. So parallel lines will never touch, and thus they have no solution. There's also the option to have infinite solutions. And what that would be is if you have a line, and your other equation gives you the exact same line. So when you graph them, the equations might be written differently, but they are the same line. We call that infinite solutions because those two lines are touching literally at every point on the line. For us to solve these by graphing, if we're going to graph by hand, we have to make sure that our equations are in slope-intercept form. The great thing about these is that you should already know how to do them. All we're doing is graphing two lines at a time, which we've already learned how to do. We've learned how to write equations in slope-intercept form and then graph them. And then you're just finding where they run into each other. So I am going to move pretty quickly through this since there's skills that you know. I'll do one and then suggest that you do one kind of as we go on. So let's do number one together. I'm going to use two colors. If you have two colors, it might be helpful for you. If you don't, it'll be just fine in pencil. But I do, if you're watching, I want you to know which equation relates to which line. So I'm going to start in number one with this y equals x minus 8. So as a quick review, when we graph that, we would start down on the y-axis at negative 8, because that's my y-intercept. That number by itself tells me the y-intercept, the constant. And then I use the number next to x. When it's no number, just it says x, I'm going to go count that as a 1. So 1 over 1, and it's positive x. So that would be a positive 1. So I'm going to go up 1 and over 1. And I'm going to do that several times just to get kind of a general idea of where my line goes. It does not have to be perfect. You don't have to do it for the whole graph, but do at least enough to continue so you can kind of do a pretty accurate drawing, because you do want to make sure the lines run into each other wherever they're supposed to. You don't want to have done all the work right, but it's just your drawing that threw your answer off. All right, so we've graphed one line. We need to graph the other line, this y equals 2x plus 1. So I'm going to start on this one negative 2x plus 1. I'm going to start up at positive 1 because that's the constant. That's the number by itself. And then my slope is negative 2. That would tell me to go down 2. And there's always, if it's just a number, there's always an assumed 1 in the denominator. So I would go down 2 and write 1. And I'm going to do that until I run into my other line to make sure that I know exactly the point where they run into each other so I can see where my lines are crossing. I am going to finish out my drawing and actually connect those dots to, that was bad. A little better. All right, so the point of intersection is right here. I just hit it with a little blue circle. That's the point where they run into each other. And to describe that point, we're going to use an ordered pair. So when we identify it as an ordered pair, we're talking like an x and a y in parentheses. We always start at the origin when we're counting for an ordered pair. So that point is over to the right 1, 2, 3. So that's a positive 3. And then down 1, 2, 3, 4, 5. So we would call that 3, negative 5. And that would be my answer. That's my solution where the two lines run into each other. For number 2, I want you to pause, give number 2 a try, and then turn your camera back on when you're ready to check, and I'll walk you through the solution. So in number 2, we've got y equals negative 1/2 x plus 9. That graph should start up at positive 9, and we go up 1 over 2 based on that slope of 1/2. Because it would start running off the graph, we can also reverse the direction. So I'm going to go down 1 and left 2. I can see that still keeps with my line, but it lets me extend it a little bit the other direction. So there's my first line. Second line says y equals negative x plus 6. So for that line, you should have started up at positive 6 on the y-axis. A slope, when it says negative x, that's an understood negative 1. So we should have gone down 1 and right 1. I need to extend the other way so that I can find the exact point they run into each other. And I'm seeing they do cross. I'm going to draw my line. And we're going to identify that point of intersection. So right here, when we identify that point, we've got to identify it with an x and a y, and we base that again off counting from the origin. So we went to the left 2 and up 8. So we would write that as left 2 would be a negative 2, up would be a positive 8. All right, we've got, I think, 6 more examples for you on the next page. So only way it gets a little trickier is if you have equations that you have to do some rearranging. But this is exactly like what we've been doing when you have to solve your equation for y. That's all you're doing. So we're not learning anything new right now. It's just the same thing we've been doing. So in that first equation, negative 3x plus y equals 8. I need to get y by itself. So I've got negative 3x plus y equals 8. And to get y by itself, I need to move the x, which means I'm going to do the opposite or add 3x on both sides. Important reminder, when you do this, we get y equals, we can't do 8 plus 3 and call it 11. We're not allowed to do that because those are not like terms. There's a 3x and an 8. One has an x, one is a constant, so they can't be combined. So we would just write this. I'm going to put the x first, since that's slope-intercept form, and then plus 8 because it was a positive 8. So that line we can go ahead and graph now. So this is my new pink line. So I'm going to start up at 8. We see the slope is 3, so I would go up 3 and right 1. That does take me off my graph, so I'm definitely going to need to extend the other way some. Let me zoom in a little bit for you. We're going to go down 3 and left 1. At least a few times. So there's my first line. Second line also needs some rearranging. Negative x plus y equals negative 2. So just like that last equation, we need to get y by itself. So the first thing I'm going to do every time is move the x to the other side. So I need to do the opposite or add x on both sides, which will leave me just with y equals. Now I see it's x, positive x, and then it was a minus 2. So I just rewrote the order. And that equation now I can graph. So for that equation, we would start down at negative 2. My slope would go up 1 and right 1. The slope is just 1 since there's no number there. I definitely need to extend the other direction. And I'm seeing where they run into each other. Let's go one more point. And we're going to connect those dots to make our line. That's close. So that point of intersection was right here. just barely see that. And so that point, again, when we label, we start at the middle. I went 1, 2, 3, 4, 5 to the left, so that's a -5. And then I went down 1, 2, 3, 4, 5, 6, 7. So down 7 would be a -7. And that would be my solution for number 3. All right, let's do number 4 together as well, just to review that first part of solving equations again, and then I'll suggest that you guys try some later ones by yourself. So in number 4, one of the equations is already ready for me, that bottom equation. Top equation needs some tweaking. So in my top equation, x plus 2y equals 4, let's review. This one's going to have one extra step. So we've got x plus 2y equals 4. Just like the last problem, we move the x first. We do the opposite. So in this one, we'll subtract x, which will give us 2y equals -x plus 4. But now I have that another step because that 2y is not totally isolated. I need to get rid of that 2. And we do that by dividing everything by 2. And I get y equals that -x. If it helps you, we can put a 1 right there. So we can call that -1/2 x plus 2. And now that line I can graph. So we would start up at +2, down 1, right 2 for my slope. Now, if you're observant, you're probably already noticing that the other line is exactly the same. So check that out. We've got in this green line, -1/2 x plus 2. So that line is literally going to look exactly the same. When the two lines are the same, they would have the same graph, of course. If they have the same equation, they're going to have the same graph. And so those lines are touching in literally every single place on the line. We call that an infinite solution. There is not only one place they cross at every single point on the line. All right, in number 5, we're going to review some of the kind of funky equations that we get. Top one, we need to do some rearranging. X plus 3y equals -15. So we need to adjust that one to solve for y. This would be a great time to pause and make sure you know how to solve for y if you want. We would subtract the x on both sides. We get 3y equals -x minus 15. And then divide by 3. So that would be y equals, again, I can put a 1 next to that x, -1/3 x. -15 divided by 3 is -5. So we're going to graph that equation. So that one would be down 5 on my y-axis for my y-intercept, and down 1 over 3 to get a few more points. So there's my first line. The reason I wanted to do this one together is that next equation seems a little kind of funky, I guess you could say. So it just says y equals -7. So remember, when we have just an x equals or a y equals, those are our special vertical and horizontal lines. A y equals -7 is going to be a horizontal line. So it'll go right through where on the y-axis we're at -7. So it's literally just going to be a sideways line right through y is -7 on the y-axis. So they do still run into each other right there. And we need to identify that point. So I'm going to start in the middle. That point is over 1, 2, 3, 4, 5, 6, and down 7. So 6, -7. All right, number 6, I want you to pause and give number 6 a try, totally by yourself. And then when you're ready, push play, and we'll do it together. Top equation is ready for graphing. For that top equation, we should have started up at 5, and our slope is 1, so up 1 and to the right 1. We can go lots of those. So there's your first line. Second line required a little bit of rearranging. So for that second line, you needed to get y by itself. So I would say x minus y equals 2. Move the x. That would be negative y equals negative x plus 2. I don't want negative y. I want it to say y equals. So I'm going to divide everything by a negative 1, and that will get rid of that negative sign. So that would be y equals negative 1. X divided by negative 1 would just be positive x. And then 2 divided by negative 1 is negative 2. So now that is something we can graph. We are down at negative 2. Slope is 1, up 1 over 1. So if you graph this correctly, you should be noticing, and if you fixed your bottom equation, put it in slope-intercept form, you should notice these were two lines that had the same slope, right? They both said y equals 1x. And what that tells us is that those lines are never going to touch. And so we say no solution. There will never be a place where they intersect. All right, number 7, I would suggest you pause and try this one on your own too, and push play when you're ready to check. All right, for that top equation, if we did it correctly, we should have 3x minus 5y equals negative 35. So we would subtract the 3x on both sides to move it. We get negative 5y is negative 3x minus 35. And then we divide by negative 5. That will be y equals negative 3 divided by negative 5 would make a positive. A negative divided by negative is a positive. So 3/5 x. Negative 35 divided by negative 5 is positive 7. So I'm going to use that equation to graph now. So we'll be up at 7. We need to go up 3 and right 5. I'm going to do it once the other way too. So there's my first line. Second line on this one also needed rearranging, but it was a little less work at least. So 2x plus y equals negative 6. We're going to minus 2x on both sides. Y equals negative 2x minus 6. And we don't need to do any dividing because y is already by itself now. So we're going to start down at negative 6. We're graphing this bottom equation. And my slope is negative 2, so down 2, right 1. And I know if I keep going that way, I'm not going to actually see where they cross, so I'm going to keep extending the other way. I'm going to go up 2 and left 1. I just have to reverse both directions, and there I can see where they run into each other. So I'm going to connect my dots, draw my line. And we're going to identify that point. That point is 1, 2, 3, 4, 5 to the left, so negative 5 and up 4. You should always have an ordered pair as your solution unless it's one of the special ones where it's infinite or no solutions. All right, last one I'll do with you. We've got another one of those funky equations. X equals negative 2 is going to be a vertical line. So your x equals lines are always the up and down lines. And it's going to go right through negative 2 on the x-axis. So I'm going to have a vertical line right here. And then we just need to graph 3x minus 2y equals negative 18. Feel free to pause and try to get y by itself before you check with me. We have 3x minus 2y equals negative 18. Move the 3x by subtracting. Negative 2y equals negative 3x minus 18. We're going to divide by negative 2 everywhere. So we get y equals negative, a negative divided by negative is going to be a positive. That's going to be a positive 3/2 x, and negative 18 divided by negative 2 is going to be positive 9. So we'll graph this equation. So I start up at 9. Up 3 and right 2 would take me like somewhere over here off my graph. So I'm going to go the other direction. I'm going to go down 3 and left 2. And I can see they are intersecting. Get my line drawn. And then we'll identify this point as our solution, and that is at negative 2, up 1, 2, 3, 4, 5, 6. Okay, so you will practice more in your class tomorrow with this topic. Thank you for watching, and make sure you ask questions about anything in the video if you need to during class.